Olivia is here. Let's wait.
Lisa's in here.
Yeah, she got picked up.
I know. It's rude.
And Trent. Grace. Grace is here. Okay. First up. Oh, I'm sorry. This isn't zoomed in. The homework I had asked you to turn in was the circuit over product rule, quotient rule. That was not from last class, but the class before. Most of you guys turned that into Google Classroom, but as always, I'd like to give you an opportunity to turn in the hard copy for full credit still, just in case your Google Classroom didn't work out for you. So if that is you, make sure your name is on it and come turn it into the basket before we get started. After we get started, we'll be considered late. So now is your last chance for full points. If you can't find it quickly, then you need to get your binder.
Or just the...
Just not the calculator one. I don't need it. Oh, just this one. Okay, that's it. No others. Okay, we got two short things we're going to look at. And then I want to give you some time to dive into our Unit 2 review to start to identify your weaknesses and all of that kind of stuff for our second unit test, which is coming up next week. This is in a week, so I will see you guys again on Friday. But one of the handouts you guys picked up is number 31, and he looks like this. And so what I did is I took the Khan Academy questions that were the most missed. So any question where half of the class missed it or more between y'all and my second period calculus class, and put them on here. I figured if only half the people or less are getting them correct, then it's probably worth talking about for a few minutes. So this was from last class, the chain rule stuff. So this first one was by far the most missed. There was one person out of 12 who got this question correct, and there's nothing wrong with this question. This would be a fine test question moving forward. So if I want to take the derivative of this, we're still going to use the power rule. So bring the power down, lower the power by 1. And then really the only extra step for chain rule is you have to always, not sometimes, but always take the derivative of the inside. And the derivative of natural log is one that we need to memorize. It's 1 over x. So that should have left you with choice A. But if you're trying to do those out of order, if you're trying to take like the derivative of natural log first and then deal with the 3, it doesn't work like that. You take the derivative of the outer part with the inner part plugged in, that's what's in red, times the derivative of the inner part, which is in purple. Everybody okay with why A is the correct answer? Okay. Second one, it's a little bit better. 3 out of 15 people got this one. But again, another.
It was with the FHS TV. They pulled me aside real quick, and I told them I had to go.
Okay, well, they need to mark you for school business.
Thanks.
I don't know. We take the derivative of this, so you might want to rewrite all of the same derivative stuff you've been using is still true. The only thing with chain rules, we have to do that one extra step at the end. So for this one, the derivative of the outside would bring the power down. Oops. Lower the power by 1. That's what we've been doing. That's the derivative of the outside with the inside plugged in. And then times the derivative of the inside. And the derivative of e to the x is e to the x. Now this one actually needed a little bit of simplifying, so there's a little more understanding on why it's hard to match up with this. But this stuff could move to the denominator. E to the x to the 1/2, and then multiplying by this puts this in the numerator. When you take a power to a power, that's like multiplying. So this is like x to the 1/2. And then when you divide things with the same base, it's like subtracting the exponents. So 1x minus half an x would leave you half of an x, or the square root of e to the x over 2. So simplifying is definitely harder on that question, but all stuff that we are required to do. Negative exponent, I moved it to the denominator. E to the something divided by e to the something, dividing things with the same base. You can subtract the exponents, and then changing this exponent of a half back to a square root is what they did to get a choice B. I feel like that was harder than question 1, but a little bit more success. 3 out of 15 people got that one right. Okay, any of those steps you want me to say again or ask for clarification on? Okay, then number 3, 7 out of 16, so slightly better. Again, I picked out all of them that were 50% or lower. So the big picture stuff is you want the derivative of natural log of something, which is 1 over the something, and then you got to come back and multiply by the derivative of square root of x. That's the inside part. So bring the power down, lower the power by 1. Red is the derivative of the big picture with the inside plugged in, and the purple is the chain rule derivative of the inside. And square root of x times square root of x becomes, so C was the answer. Okay, good with that one? Yeah.
I don't understand what the second part, what is
This part,
it? Yeah.
this is the chain rule part, the derivative of the inside. That's what we practiced last class.
So it's x to the 1/2.
Uh-huh. So I just, because we do this one all the time, I just did it real quick. X to the square root of x is the same as x to the 1/2. So power rule, if you brought the power down, lowered the power by 1, it looks like that. But then because it's a negative exponent, you can put it in the denominator. And then an exponent of a half is like the square root. It's just that we do that one so much that I can just do it real quick. But I just skipping those steps. It's not one that you really have to memorize, but it is comes up often enough. It is a little bit of a shortcut if you do. Okay, anything else about number 3? Can do that one now? Okay, and then number 4, 3 out of 9 people got this one. And I don't know, I thought this one was okay. What's the derivative of cosine something? Negative sign of the something. It stays the same stuff. If it's an x, it stays x. If it's a 5x minus 9, it stays 5x minus 9. And then notice, I really like, I guess I didn't pay attention to this on the other questions. Notice how that answer's there, but it's not the right answer. That is going to be a common distractor. They did not multiply by the derivative of the inside. Chain rule, it's got to be 5 times bigger than that. That's why D is the answer, not A. Okay, good with all of those? Again, I don't think those are any more difficult than things you're going to see on the test. So if there's something about these that it's not clicking, now's your chance. Okay, next up, you don't have to do this on a piece of paper, but I do want to take a few minutes. There is a card sort activity I have where there's some position graphs and some velocity graphs, and you have to try to figure out which ones go with which. So with your table partner, go ahead and try to match up. The velocity graphs are all green. Position graphs are all yellow. Everything matches what you want to do. So, none of these give you the function, so how are you supposed to know something about velocity from position? What's the relationship between those two? Velocity is the derivative of position, and how are you supposed to know something about the derivative if you don't know what the function is? Slope. Derivative means slope. So the slope of the position is giving you info about the velocity.
Can we look back at our notes?
If you want to. So when you, oh, did I not bring you some? All right, when you think you've got them all matched up, have me come check your answers. Okay, when you think you've got them all matched up, have me come over and check to make sure that they're correct. And then you can move on to the test review. We'll talk about it as a group. What? Oh, I didn't know if you were asking.
Because usually, this is obviously unrounded. So parabolas, they start here and they go, sorry, but when they go up, they go 1 to 1 and then 2. So like 0, 1, 4. This is going 0, half, 2. So it's going to be half, and it's going down. So it's going to be negative. So negative half x squared. Negative half x squared minus negative half x minus 2 squared. That's negative 2. It's just a constant quantity. So half, negative half x. That would be 3x.
Yeah.
So negative 3x over 2 should just be like a line that goes
Derivative of position given.
So the velocity is going. Mr. Johnson, could you help us with this?
Yeah.
All right, so just pick a position graph. Doesn't matter which one. Okay, so if velocity is supposed to be the derivative of position, and the only way for you to know something about the derivative is from slope. When is the slope negative? When is it positive? When is it 0?
So one second.
So find a graph that has a negative velocity, a 0 velocity, and then a positive velocity.
Okay, so
So when you said that it's 0 here, that means it should be an x-intercept velocity, right?
Yeah.
That's where it's 0. So find a card that has an x-intercept of 1.
Because of their shape.
right here,
Yeah.
and also right here.
This one is negative, a 0, and a positive too, so.
I don't think it should be
This
that
one?
one.
Could it be this one?
Is it
No, because
negative
that's
to
not.
1? That's not, yeah, be 0.
So is it this one?
Is it negative from 0 to 1, like the slope is? Is it 0 at 1?
Slope is not
We only care about the slope of this one, get you information about that. This is negative.
Below the x-axis, zero slope, zero slope, positive slope, positive means above the
So this, these two.
those two look like they might go together.
Okay, that makes sense. Thank you.
What was
Okay. So this one.
And at four.
We need to find like the slope. Positive or
Yes. So
So just telling me.
but that also
Derivative means the same thing as slope.
here.
So what kind of slope do you have?
And because this is this one because this is negative. This is negative.
Yeah, and so it's negative the whole time. And so find that velocity is negative.
This one's zero.
The slope of
Oh wait, no. It's not zero. It's only zero.
it's not positive, it's just because it intersects y.
Or is it this one? This is the negative slope of no. It would be the like opposite.
this one goes to that
Positive and negative.
Oh.
Well, positive after zero to, I think they're both zero.
Yeah.
Yeah. No, it's right. So that sounds like that might be.
Go down to positive. Yeah, like it's half.
Well, kind of complicated for this one.
This one has a zero.
This one.
Negative until it gets to
If
three.
you're not sure, then probably. Pick one of the position functions, and let's just work this one. So, derivative of position tells you something about velocity. The only way for you to know something about this guy's derivative is from his slope. So, when is it slope zero? When is it slope positive? When is it slope negative? Explain those. Tell me that. Yeah, from zero to zero. Okay. So that means the derivative is positive and two. And it's also zero.
Zero and two.
And it's negative. So his velocity graph needs to be positive, zero, and then negative. So it's positive means above the x-axis, negative means below
Or
the
negative
x-axis.
until.
So find the velocity graph.
So
Above the
yeah, this
x-axis,
one's- it's
zero, and then below the x-axis.
this one.
That could very well be it. So I would raise those up,
So it's positive.
Put 'em aside.
Zero.
and then try to go to another one.
Is that right? Is that, oh yeah, that's positive to one. Negative.
Two.
Negative to one.
Yeah.
So yeah.
Okay, get started.
Zero.
This one.
So you have to remember that the derivative of position is how you know something about velocity. And derivative means the same thing as slope. So when I'm looking at this one's positive, slope is zero, slope is positive. So that means this guy should be positive, zero, and positive. Slope is positive, slope is zero, slope is positive. Because that velocity should be positive, zero, and positive. I think those two could work together just fine. So pair those up, put them aside.
Has a zero at two.
Now keep them together.
They're both positive. Or they're both
I
like.
think it's a safe bet.
Two
that those are
zeros,
correct.
positive, negative.
Okay, now pick a different position function. It doesn't matter.
Mental one.
So think about
Positive,
positive.
so
Positive is above.
Okay, so velocity, where is it? Negative, zero, and then negative.
So for this one, the velocity is position, and the position is.
It's not zero
Or
here.
the velocity.
Yeah, that looks right. So pair those up, put them aside, and then start narrowing.
Actually, no, what I do is.
Roman numeral 1, or hard 1 goes
it's negative.
Is there one for each
Well,
test?
Even though you're wrong.
No, I don't know.
What goes with card 2?
No, but this is negative velocity.
Okay.
Alright, what goes with card 3? Yep.
Wait,
Card 4.
negative 0.
Six. Positive. Yep. 5.
8.
Yep.
Like if one of these was like.
Well, it looks like
the
there's a
X
curve about to start right
cubed,
there.
the derivative of it would be X squared. So in return,
You do
it's
it?
trying to figure
Yeah,
out.
you got it. You got it.
1.
I'll just leave it.
Yeah, in return, it's like that. Does
10.
that make sense?
Why not?
Well, if you took the derivative of this, this
Oh,
X
yeah.
cubed would be X squared.
Scramble them up in the back of the bag, and then move on to the W.
So I feel like these are pretty well, like not specific, but I'm just saying that it
Negative.
would look like
It's
this.
just negative.
How long it took you to write that?
And then like the ones that look like this already would turn into like a line. Because if you X squared, that turns into 2X, just 2X. So,
Yeah,
because I feel like that one's definitely wrong. 2X cubed.
Zero. Negative.
I feel like that one would not turn into.
See this one right here?
So it starts at negative. Or no, it starts at 0, so it's
It's going down,
negative.
right? Negative.
Or
So from 0 to 1.
0, negative.
0 to 1. At 1, 0.
Yeah, it
From
starts
1
with
to 3, it's positive.
Oh.
It goes 1 to 3, positive. And then at 3 it becomes 0. And then from 3 to 4 it's negative.
0, negative. 0, positive. Negative. Wait, maybe.
Velocity is
It's the
the
opposite.
So I guess this one.
You're right.
Oh, so it's, yeah, E is good.
Yeah, give me the yellow one.
You might have been close, you know.
Positive,
Because I feel like we did them all.
negative. So velocity starts at 0, and it's positive, so it's 0 x.
You're running out.
And it's negative, and then it's 0 x.
Oh, okay.
Do now?
It's oh, it's
Well, now it's calculus stuff.
0.
Well, which one have you tried that you circled? You on then?
Yes.
I need to check.
What is this?
There's a card number 1.
so positive, 0,
The year. Oh.
negative,
Even if it's sideways, it's still.
Position 1 is
positive, 0.
Not the Roman numeral.
So do we? Actually, positive.
Okay.
That's a good
Five. 6. 7.
But it's like,
Scramble them up, put them back in the bag, and then start a few questions on your test while you wait.
So positive and zero. Negative zero. Then positive again.
Okay, so it's 0 2 times, so you need to find one that has an x-intercept at 1 and 3. So this would be here.
But it's gonna go negative.
Right. What about this one? That's positive, right? Above the x-axis. 0 at 1, then negative till 3, and 0. Yeah, those two look like they go together. What's hard is you've got to think about slope on this one and not
Yeah.
slope on that. If you start thinking about slope on this one, then your brain's going to get twisted.
Okay, so
Again, when you finish, let me check. Number 1, not room number 1.
yeah. No, 1 or no, yeah, 1 and 3, 1. It's not that one. And that's the start. That's it. Oh yeah. Yeah, yeah, that's it. Zero and
Scramble those up, put them back to 0.
I see what you
You have to switch them, but scramble them, so you don't know what you're
starts negative.
True.
That's crazy. I need it for a red do I have to draw? I have a straight number. I do that.
Maybe that's has to start negative until 2. And then that makes sense. Yeah, because that's yeah, that's negative until
so we're lost.
or no, it's negative to
Take a position function.
and it's positive.
It's like the sideways of
So the derivative of position given velocity, and derivative is basically the same thing as slope.
So it
So
starts
I'm looking at
negative.
slope. Slope is negative, slope is 0,
Zeros are
positive,
1.
slope is 0, slope is negative.
0.
So it sounds like slope was 0 2 places, and x equals what?
So it starts negative.
Okay, so we just find the velocity graph, I think 0 is 1 and 3. Okay, that could be. Okay, so then negative slope from 0 to 1. No, you're looking at slope here. I'm asking if it's positive or negative. Negative slope means it should be negative here. If it's above the x-axis, it's positive. So that's the best one. the zeros where they need to be, negative slope, negative value, positive slope, positive value, negative slope, negative value. So these are probably after those is 0, one more 0, 0, 0. So 0, 0, 2, 1.
So that's negative.
Velocity that's 0, I guess. Okay, and so over here, between 0 and 2, the slope is so that means the velocity is going to be what? Between below the x-axis. And then 0 and 2, that goes slope is 0 and 2, so it should be at 0. Slope is positive, negative, the value should be positive. Those two look like those just go. Okay, and then she gets easier to play. Make sure you keep me that.
Oh, and then it turns negative.
Negative.
Right?
That's not a 0. And that's not a 0.
Yeah.
Okay.
Does anybody need a stapler?
It's supposed to square.
No stapler?
No, not particularly.
Minus.
Oh, we can answer that.
So the 0 at 2.
I was like, oh, no one else can do something.
So the 0 at 0.
Agree with all these. Those ones coming back to back. Okay.
We were kind of confused at the beginning, and then you started getting it toward the end, so.
Positive slope, velocity should be above the x-axis, negative slope should be below.
Yeah.
Slope is 0.
Yeah, we got that.
Positive
Yeah, I'm sorry, sir. I was thinking.
Okay, so what card do you have with number 1?
Use this to figure out what the parts of it is.
Okay, and then 2?
I said it was 3 because g part is 3 is full different. Where g of x equals 2 to the power x. So that's g part of 3, 5, x is equal to 2 would be 2 to the power 6 minus 2 to the power 3. That's what x is.
This is also.
7.
So we got 0's at 2. 0's only at 2. And then it's
5
positive
is the
negative.
same thing, but the alternative.
Okay. 11.
This is.
Is at
I was never tell.
12.
less than negative 5.
And 13.
Negative
These are the right ones, so scramble them up and put them back in the bag. These got mixed up, so you gotta reconsider these.
Yeah, positive or negative, or the 0 at 2.
Alright, where do you have number 1? What card goes on?
0's at 2. 0's at 1.
Okay, number 2.
Oh, wait, is. Yeah. But wait, if is 4 and y is F1.
5, 6,
Oh, so that's 0.
It's
Because
negative
because it's
positive.
cosine 0, cosine 0. Yes, because it's cosine 0 is
9, 10, 12, 13.
because it's not A or C, because that's just
These are all correct. So scramble them up and put them back in the bag. But these two you had mixed up, so you need to try them again. Try to figure out why. And I'm scrambling up your answers so that you may not remember.
So that's to be B or C.
These are the
D,
two.
and we determined already that it has to be.
Yeah, then I need to know what goes with card number 1.
Seven. Is that one? That's 6. Seven. No, no,
You have to find Oh, wait. You're right, that would be 6.
So we didn't have one.
These are all right.
Yeah.
Scramble them up. Okay, and then start on a few questions on the first.
This is positive until 2.
So we treat the 6. So we have the 16, we need 2, 60.
Because sure these are right.
This is positive.
I'm
So how do we make the distinction?
Well, we have sort of the same these are more. My brain.
Yeah, I get it.
So
Wait, but this is only positive.
think about like x at 1/2. This is slope here. So where's the slope here in x 1/2?
Wait, this is positive.
Oh,
so
So you just had to like focus in a little bit more than just
yeah.
Other than that, isn't
Now,
it?
now.
So I
Scramble those up. Put them back in the bag and then start putting questions.
Okay, yeah, I think I understand. Yeah.
It's like whack-a-mole.
Okay, good with that. Not good at this.
So that's all we're doing for the rest of the period.
You don't have the answer out that goes with it. That's not on me.
You told us to put those up. You had those in your hand.
Alright, this, okay, hit out number, this is supposed to go with 3, Roman numerals. So let's compare this graph. Positive, 0, positive. Positive, 0, positive. So, that's why these two went together. Here, this wouldn't have worked because this is negative slope, so it had to be negative here. Non-negative, you don't think of the slope as velocity, you're just thinking about values, only slope of this one. So that's why this couldn't work. These two go together. Okay, and then those are okay. And then This is just not even, we don't really practice it. Either.
Is this on the exam?
It could be 3.
Very much so.
Wait, well, last year wasn't it?
Yeah, there's always one that complains about.
Yes.
Okay, so here's position. Here's position. So looking at slope, it's negative, and then the slope is 0. So this is negative values because it's below the x-axis, and then it's 0. You shouldn't be looking at slope of velocity unless you want to know something about acceleration. Okay, then it's positive from 1 to 3, positive slope, so it should be positive values from 1 to 3. Slope is 0 at 3, should be 0 at 3. Negative slope from 3 to 4 should be negative values between 3 and 3. That's why those go together. Okay. Positive slope above the x-axis, 0 slope on the x-axis, negative slope below the x-axis, positive slope.
I was just a little.
You can try again if you want.
No, I think I learned a lot.
Okay. Wait, there's one later we do in the year where I think I don't even tell you which ones are positions and which ones are velocity, and you have to figure it out.
You can, does it have markers on it?
No. I'll come in there next one.
And no, check these.
The solutions are on the website.
Oh, they are.
I just knew that I didn't
Okay, give me just a second. I'll get this over there. Get their okay. Why they do what they're supposed to be. Okay, put those back in the basket and then do a few questions on the other.
No, it's just
Yes. Yes, but it's on the bottom.
So it's X to the 1 or X.
That's why.
And then it's X to the
7
And then with this we put
Okay, I'm going to come around and pick up those cards here in just a second. Again, there's not any documentation that you need to have for that. It's not really for a grade, but hopefully it helped clear up that connection between some of those. Okay, so all of you guys should be on the test review now. So I want to give you a good chunk of time because I do need you to try the rest of this for homework. So the more you get done in class, the less homework you'll have. But just talking about the structure of the test review. So this can't, you guys don't want a test review that makes you practice 50 of every question type again. So this is supposed to be a sample. So looking on the front page, first thing it talks about is the standard definition of derivative. It tells you that you need to know that, and you need to know the alternate form. If you don't know those, find them in your notes to copy them down, but you need to know them for our test when we get there next week. And then there's 3 practice questions, 3, 4, and 5. So that gives you a sample of if that's a skill that you know, or if you have to look up your notes, or you have to ask for help, or you got to work with your neighbor, then you probably need to try those questions again before the test. Next section's on power rule, so writing out what the power rule is, and then one practice question, and then I have some links if you want to practice more power rule, although you're probably okay. Back to the page, product rule. You know what the product rule is, write it out for question 8, and then can you use it in 9 and 10? If you know how to use it, you should be able to get 2 questions right. And again, that's just trying to help you identify what things you may need more practice on. I've got some optional extra practice links that you need. You know, difference quotient, what is it? Try it on 2 questions. What is chain rule? Try it on a couple questions. Just a quick sample of all of the things that show up in units.
So, a tiny bit of practice, but really it is mostly to help you identify what you need to continue to study.
And I intend for the solutions to be on my website, but I think that they're not yet. So give me just a few minutes to try that, and then actually, I'm gonna come get the card. You already take all these cards.
Oh, I think so.
So you gotta find the derivative, same old way. And then if you want to know the derivative at that time, you're gonna plug that next value into the derivative.
So which one is this? Which one is this? Is it manufacturing? Okay, so we got a bunch of employees. This is this is a function that the next state plugged in. Looks like the function might be x.
So it's gonna be one of these where this function is 2 to the x. Not this one. Not this one. So eliminate A and C. So cross those out. Okay, and then this is supposed to be the function, but they're actually plugging in numbers. So if I think the function is 2 to the x, and they're plugging in the 3, they must want to know the derivative at 3, not at 0.
But if you gotta have these two memorized, so that when you're reading it, you can figure out, get enough clues to narrow.
It's like double. Because 4x use it up. You have to have the parentheses for it to be You're wondering if 4x would be the inner side or not, because there's it is the
gotta do camera twice.
Cosine 4x
Oh.
Again, let me get these test review solutions up so you can check your work, and then I'll come around and help.
like this. So it's 4 cosine over 2 square sine 4x. Those cancel out. Yeah, it's 17x.
Figured out this one because
Oh, wait, sorry. I was thinking that this graph was part of it.
Okay, the solution should now be on the website if you want to check the work as you go. You'll have to refresh the page, though.
Or you even simplify each variables. 2t.
We do it at the same time. We do like this. We do sort of left. Do product at the so f prime of x. X. So you don't actually have to do it right now. So what you got, you stick. So for your first one, it's the derivative of t is just you just put something t squared because you're just keeping it as a derivative. Plus, now you keep t out, and then you have to find the derivative of sine t squared, which is cosine
Mr. Johnson,
t squared.
for number 3 in the test review, is it B or
Is
C?
the derivative of t
Because it
squared.
looks like you wrote both on the thing.
I wrote both on there?
Like, one's over the other, but I can't tell which one is. Like you wrote, like.
No, yeah, because that's not counting the derivative. It's just the.
I'm assuming you were,
Should be
yeah, okay.
the functions to the
Yeah. Yeah. I know.
Okay, 2t times t will be 2t squared.
Oh, the g of it is between derivative of t0 versus derivative of negative 2 curves 2. So you're okay with y to the x? Yeah, I can get y to the x.
So then it looks like the number they're plugging in for x is 3. So the calculation,
You have to remove the greatest.
oh, see, that makes sense.
Could you explain one more thing? Sorry.
This
I got,
this one
so for this one, you have negative 5 over 64.
This is
I
velocity.
got negative
This
5
is
over
a
60.
position.
Yeah, 2, 4,
So it should be
16.
from 0 to 30.
Because 2 to the third is 8 times 2.
Because also just the number just shows the speed, not the.
Oh, it's negative 6.
And you do shockingly well. Why that?
We're actually not really sure on that.
Did you say that this was B or C? C.
Yeah, because like, as soon as you figure out that this is the function, it looks like they're plugging in 3 for x, so they must want the derivative at 3. So it should be
B. Okay. Yeah.
Because that's for position.
this one's
For
right,
position,
but on this one,
this is velocity, so it's showing like its speed across the map.
matches up to
So
one.
think of it like this. Not think of it
So
as
right here,
at
missing some stuff to this guy.
20. It's
We're trying to find the derivative at 0. So
It's
a
like
should be 0.
going this way.
The denominator should be
It's
x
not
minus
that it's going a certain way. It's going down. It's that it's going down.
He has b defined.
So at
And if
20,
I'm right, this is supposed to be
wait,
the
no,
function at a.
at 10, at
So
10 seconds,
cosine
it's
of
going
0 is
60
1.
miles per hour. At 20 seconds, it's going 40 miles per hour.
This one's missing.
Which is
so it
still
can't be
also
right.
to the right. It's just different speeds. But when it's negative,
Prime
it's
zero.
at 40.
This is finding the derivative of g at
So when you're talking about velocity, negative just means going the other way. So when it's negative, it's
you're trying to describe what this is right. This is
and when it's at best is when it's when it is zero.
This is finding the derivative using the definition. Remember, you don't have to do the definition by hand, but you have to be able to match it up well enough to figure out questions like that.
Each time
She just like here, watch this. Have you ever seen that channel?
This, I don't know. Good luck.
It says each time, that just means when it changes.
Yeah. Yeah. Like, it should be the same all the time here, same all the time here. So, yeah. I can't make you do every time because you're not going to do 0 and 1 and 2 and 3 and 3.5 and 3.1 and 3.11.
That's what I was thinking.
Yeah. So
Okay.
just the intervals.
Got it.
Wait, are you on that page and then read it back?
No, it's 1, 2, 3.
No.
1, 2, 3. It's the third page. And we finished the errors.
Oh, okay, yeah, it's a lot.
This is the same thing as the
Yeah, it's like the same one.
Yeah.
Okay. The acceleration.
I really suggest any questions that you guys missed or you struggled with or there was something you didn't know, mark those questions and go back and try them again before the test.
I did it right. I just simplified it in the weirdest way possible. Didn't get it right.
Well,
That's just
as long as it worked.
yeah.
This you can, if you want it. I know, but if you finish it and give it to me before the test, you get half the points back.
Since it's like,
It should be 70.
Could be. If you're a math major at the college, it doesn't really, they won't count your credit unless it's at least 60. Probably if you're an engineer too, if you didn't have at least a 70, they would count, they'd ask you.
well, I think in high school, cause like, no way I'm gonna get back.
Well,
I just want credit.
there we go.
gotta get higher and good, you just gotta do that.
I can't remember my work today.
Well, you know, it's in Google Classroom, so you check your school email, what
If they like you're supposed to, then possibly doesn't get.
I do, but I just don't click on anything. And that doesn't help. Everybody know? That's a lot of fun. Make sure you have it done before
Yeah, but
Friday.
this is it.
Again, I need y'all to try all of this test review by Friday, so you know exactly what to come with.
Intervals I used to do this for. So here it is. Yeah, parentheses, 0, comma, there's. I thought I was going back best you can do is like units over time. So like when something's moving, you can say that. Time is just a general acceleration. It would be unit, you don't know what it is. Unit over time squared. You know what you were supposed to do with scenarios.
No, I'm saying how much you got done, so when I come back. How much you got?
One question, 12. Yeah, I'm just gonna get 13 and then you have to add it up to 1.
No, I expect, depends on how soon I come back.
Come back right now.
No.
Do you have like a stapler? Oh,
Over
can I
there.
use that one?
Yeah.
You saw this, you saw the geometry, and
It's just derivative.
Oh, yeah, I know about that.
We can do single more than one. One time we do the square root and sine 4x is your inside. And then when you take the derivative of the inside, 4x is the new inside, and then there's x.
Okay. Sounds fun. Do the derivative.
Choose project start.
What's up?
So were they right?
So, when there's something inside
This actually got them straight.
that's also,
Sine probably takes you down, but then you also need to realize
There you go.
that's something that's down for it. Memorize.
so like, if it was just cosine x,
You
you
can start doing a little bit of it now.
4 of
Don't wait
those,
till
then
the times 4.
because it would just be cosine and that would be the moment you go against the one, then you go against.
Probably Friday.
This one? Oh, yeah, this one.
But there's 4x. The next one right now is football.
So when does
With X comes first, I think we used my grandma's old.
that's right.
The other side.
Mr. Thompson,
You got too much to do.
would the school be okay if I brought my grandma's old scooter?
No.
Why not? It's anything but a backpack.
You can bring it, but you're probably gonna be in ISS anyway.
For what?
Not doing your work.
Okay, come on now. That's very, I'm doing my work, it's just at a very slow pace.
Okay,
But you know what? The truck will beat the hair.
Okay, good. So, we're gonna have a better test review on Friday.
Take the derivative and then plug it in. So it's
But I'm not consistent. I'll probably think about it pretty good.
like we did here.
Excellent.
Well,
Every 2 hours, I'll do one problem.
Next one is just the X division.
So this is usually good.
You're gonna have to
We gotta tell you where we want
X
to.
is X.
Okay, let's find the y value. You're gonna put in the x value into the construct. You're gonna find the y value.
X, Y, that's an X.
Say like,
The next one
So it's just.
into the function. And then x and y solve for y.
And then it's Y when it's
Slow. The derivative at that x value. Really, it's probably gonna have x at all.
questions, like one you'll ask some questions actually say at point 1, 2. So they're giving you X amount of handle. So sometimes we don't need to. She just doesn't want you to do this. Yeah, so you have to understand. Like she writes the function to find points, like X interval, and she just doesn't want you to do it. It's all points.
Well, that's still really nice.
Yes. This no. Y'all, I'm about to move y'all different classes.
Different seats.
To me, is the front width. Those just take lots of practice.
2 squares.
That's why I went to like that's the Khan Academy. I've already done it, but honestly, doing it a few times is what makes you feel more comfortable with it. And unfortunately, we don't use that for anything all year. So then when it comes time to review for the AP, we got to just kind of redo it and memorize that process.
Yeah, this is not like it's just like memorizing doesn't do it.
Well, what we just did with the card sort should help.
So is it just like whenever it's negative?
If velocity is positive, it means you're going right or up.
If it's the
Negative, you're going left or down.
and then the rest it's
0. So it's not positive or negative.
but so that's still technical.
Positive.
Okay, so then that would be good.
And at 0.
Okay.
And at 55.
Okay, yeah.
Then for acceleration, then you need to start thinking about slope. Just like the slope of position helps you figure out something about velocity, which is card sorting. Or the slope of velocity helps you with acceleration.
Okay. It's all right.
Okay, so 1 or 2 I can help with? No, that's it. 1 or 2 I can help with?
What did you say?
1 or 2 I can help with?
I was just wondering how the constant, if the constant 0, the relative constant times the function 0.
Well, so like the derivative of 2 is 0. What's the derivative of 2x?
2.
Right, it's 2 times what the derivative of x would be.
Okay.
See what I'm saying? So that
Yes.
it just makes it 2 times bigger.
Okay.
So it has say an acceleration of the particle every like change.
You got to see.
For like negative slope, would you put like negative acceleration is negative there?
Then you put that in like negative. So you put that into theta, and however for it, the way I did it was just 1 over cosine squared, cosine. Yeah, 1 over cosine. So cosine of that is square root of 2 over 2. So if you do 1 over that, you just flip them. So it's 2 over the square root of 2. But you can have a radical on the bottom. So then you have to multiply it. So you multiply both the top of the square root of 2. And then you have 2 squares of 2 over 2. And so you have 2 2s, they cancel out. And you're just looking at the square root of 2. And now you have to square that because it's secant square, not just the secant. So the square root of 2 squared is 2. is it? I got two. So then you put two.
You still have the little pinball shooter thing?
Y minus y one.
Oh, yeah, I'll what's it to you?
Oh, well, I just remember that from last year. You put this in a tricky spot. I can barely write my name.
Okay, so leave your phone instead.
Well, I like writing my name.
Okay, well then don't
It's
complain.
good practice. It's good practice, yeah.
He thinks he's gonna wear me out, but I'm definitely gonna wear him out.
Do what?
God drove Mr. off the wall last year.
What, Mr. Johnson?
You'll find out.
Okay.
I got a secret for you.
Are you gonna move me classes? Yeah.
All right, you'll still have about 12 minutes, so should be able to get a little bit more done. So using this graph, you know the velocity over time. So you should be able to tell me when something's moving, when it's moving to the right, left, and at rest. We did, I think we may have done this exact graph on one of your desks from a few classes ago. But there's a couple more in there.
Here, I'm gonna put y minus one equals two x minus pi over two. And then to simplify, I will divide it by two. So that's not the margin anymore. So two y minus two equals four x minus pi. And then from there, we get the x's and y's in the same side. So, subtracted four x added two. And then, got rid of negatives, so it's four x minus two y, so those two are. Oh wait, I got wrong. That's, I meant secant, cosecants.
Oh, wait.
Usually, yeah, but I was listening for usually your cameras.
Because if you change one over
I heard
to
you come, since I've got like super sensitive, and I was like, that's what September, I got that. So I'll let you in. Maybe we would telepathically, like, connect with this. Wouldn't that be cool?
It would be cool. Because then you would know what I'm thinking, and you're just gonna do it. You're gonna think it without. So I don't have to say. Yeah. Did you hear what I said?
Technically, if you want to.
No, I did, get my work done.
There you go. You got it.
Would be 2t to the negative. So that would be negative 2t to the negative 2. So it would be 2t negative 1, I don't think you have to do those, but if you did have to do one, I'd probably be easier to do it portion.
Okay, you guys are down to about 5 minutes, so find a stopping place, start bringing my calculators back. Please finish this test review, try all of the questions so you know what you need help with. I will take your questions next class, but if you don't do it before then, you don't know what you need help on, and then you're more on your own to get it figured out, so.
Justice.